Hey, Jody here. This video is brought to you by my online store at weldmonger.com. Today we're doing a little MIG welding, a little out of position MIG welding on a tube to a plate. It's a 5F position, short circuit MIG. Let's do it. I thought I had a piece of plate in the shop big enough to do this little practice piece with, but I didn't. So I'm just welding 3 pieces together here. And I guess that's a good thing because that lets us weld some downhill roots. Get a little practice on that too. These pieces are only 1/8 of an inch thick, but they're actually pretty good practice for just basically learning the skill of where to put the wire in the puddle on a downhill route on an open butt plate or pipe. If you keep the wire too far in the front, you'll shoot wire through. If you keep it too far back in the puddle, you won't get the kind of penetration that you need. I'm going to be using the Miller Multimatic 220 here, and I'm using the auto set function, so I'm just going to default to what it told me to use for 1/8 inch steel. I thought it would be kind of hot with this gap in here, but going downhill it actually was pretty close. 532 gap. Again, I'm just going to try to keep the arc on the leading edge of the puddle, but not too far so that I shoot wire through just right on that leading edge. There's really not much of a way of describing it without actually doing it. You just kind of have to get the feel for it, get the sound for it, experiment with what's too far and what's too far in front of the puddle and what's too far in the back of the puddle. But you figure it out pretty soon. And you can tweak the wire feed speed to adjust that profile on the root pass side, but you don't want too much wire feed speed, or it just really does tend to shoot the wire through. I'm getting a lot of forgiveness here because this is 030 wire. I've got a lot of variation in what I can set the wire feed speed and not shoot through. If I was using larger wire like 035, have to be a little bit more careful with the wire feed speed. I would be using 035 on a root pass on a test plate or an open root pipe more than likely. Gun angle, pretty much quite a lot of angle, like almost 45-degree angle. That makes a difference too on the profile on the back side. Honestly I'm surprised it's not just really blowing through at this hot setting, but that's downhill for you. Now we got that sewn up, we can go ahead and tackle the tube to plate joint on the other side. Now the other side, since I'm going uphill and since I'm going to have to sort of continually reposition my hands and my body and everything to maintain some type of a favorable gun angle, I'm going to turn the wire feed speed down just a little bit. This gives me a range on here for that voltage, even though I'm still set for 1/8 inch material with 030 wire. It gives me a range, and I'm going to drop it down to the bottom of that range just to kind of slow things down a little bit, give me a chance to maneuver. And this is the technique that I'm going to be using, a little upside down V, because I want to keep that arc tracing the front of the puddle and penetrate into the root of the joint. Now what I'm thinking about when I'm doing this is I got an email from a guy who's having some trouble on some leaks, on some fittings, on some tanks he was welding. And so that's what I've got in mind with this technique, how to make a leak-proof joint. And this is kind of what I would do to make a leak-proof joint. This is the technique that I would probably default to, because it traces the front of the puddle. It doesn't necessarily make the prettiest weld, but it has always worked for me as far as just making a sound weld that doesn't leak. And speaking of leaks, the less restarts you have, better off you're going to be. So I'm going to try to go all the way on both of these from bottom all the way to top without stopping. And I'm just going to pivot. I'm holding my MIG knuckle heat shield there on that pipe. It's not going to let my hand get hot at all, and it just lets me pivot and make one whole run and kind of steady up the piece too a little bit, because I'll be propping on it. You can see it's a little bit wobbly. I need to build a better stand. One more little quick view of the little pivot here before we get started. That should maintain a decent gun angle for me. There's a lot of leeway on gun angle. I don't have to have it within 1 or 2 degrees, but I don't want to get too much of a push angle as I get all the way up to the top there. A little push angle coming up the side will work just fine, but the tendency will be on the very top to get out of scope with the gun angle and have too much push angle. So here I'm just doing that little upside down V, trying to watch it and trying to drive the puddle right down into the corner. And again, I'm using the settings for 1/8 inch. The tube itself is 3/16, and I did drop the wire feed speed down, so it's close. It's manageable. It's controllable going uphill without it crowning up too much. Probably could use a little more wire feed speed, actually. But it's doing okay. Again, the upside down V, tracing the front of that puddle, trying to hold my stick out to less than ½ inch, somewhere around 3/8 of an inch. And the thing about stick out is when you think you've got 3/8 of an inch stick out, you probably got ½ inch at least. It's always more than you think. I see this all the time when I'm filming my own welds. I think I was holding a really short stick out, and I wasn't holding as short as I thought. So shoot for a little less stick out than what you think. Probably things will go a little bit better. Got my son-in-law Garrett helping with some filming there today. Trying to get as many different angles as we can. Trying to help show hand positioning, elbow up in the air. All these little things that make a difference when you're learning. Now, on production parts, on repairs, on weldments, a lot of times there's one attribute that's more important than all the rest, and sometimes that is having a leak-proof joint when something's going to be pressurized or hold liquid. And on short-circuit MIG, it's a helpful thing to feather the start. You can get a cold start if you don't have a good ground or whatever. Short-circuit MIG, you can have a cold start, and then when you restart on that going the other way, you could have another cold start, and that's the place you're going to have a leak more than likely. So by feathering it back a little bit like this, gives you a chance to light up on the beginning of that grind area, gives things a chance to warm up and burn in better. Here's another thing. It just happened. I happened to notice this. I've got a big ring of spatter hanging there. Remember to do a little quick inspection, clean your nozzle regularly, or you'll get that thing dumped into your weld, and sometimes it's kind of hard to clean off. All right, here we go. Let's start up on that ground tapered area. I'm trying to just sort of wash everything in and then do that V technique to get into the root of the joint. Once again, I'm taking the arc up toward the front of the puddle, tracing the front of the puddle so that I melt into the leading edge of the puddle, doing that upside down V, trying to change my gun angle as I go so I don't get too far out of scope as I come up to the top. Almost done with this one. So as soon as I tie in there, we'll take a quick look at that bottom area where I tied in, that area where I feathered with the grinder. I did pretty good. I would like for this to look better. It's still a little bit more crowned up on the bead than I would like, but I think it's in there.